Hello students, welcome to today's class. Today our topic is Nicols prism. So what is this Nicols prism? Why we are using this Nicols prism? So in our previous class we have discussed about the double refraction. When unpolarized light is passing through the anisotropic crystal, after refraction it will split into two rays. One ray is called as ordinary ray, another ray is called as extraordinary ray. Even though the angle of incidence is same, but those are divided into the two rays. Okay, that means by using some divisors, we will eliminate one ray from out of two rays. Why we have to get the plane polarizer light? Okay, now Nicols prism. This Nicols prism was constructed by William Nicol in 1828. By William Nicol. This is the scientist name. How he was constructed that Nicols prism? Okay, let us see that. So he was taken a calcite crystal. He was taken a calcite crystal. Calcite crystal is an anisotropic crystal. Okay, that is actually in rhombic shape. That is in rhombic shape. These corners I am taking as A, B, C and D. Okay, now I am cut that crystal, that means reduce the corners, so like this. That means A becomes A1 and C becomes C1. Initially its angle is 71 degrees. Initially 71 degrees. We are converting that to the 68 degrees. So that means whose angle is 68 degrees. This calcite crystal length is 3 times more than the breadth. Like that we have taken. And here this is 90 degrees and it is also a 90 degrees. Now the line you have to draw the joining the A1 and C1. Along the direction, if you take any ray, okay, that means I am taking one ray like this. If that ray is making equal angle with the edges, then that ray is called as optic axis. Optic axis means the axis passing through the blood corner which make equal angle with the three edges. Okay. Now we have to divide this total crystal. Okay. So along this direction. That means you have to divide this one. If you are dividing that one, automatically it is split into two parts. Okay. So like this it is one part and like this it is another part. Generally these parts becomes, whenever you are cutting, those parts becomes rough surfaces. As we know that from the rough surface the light won't pass. Okay. So to pass the light through them, you have to polish them. You have to polish them. That means you have to make that one crystal into a smooth surface. Then by using one type of material, you have to add them once again. So like this. Okay, which is the material we are using to join them is Canada balsam. Canada balsam. Canada balsam, whose refractive index is mu equals to 1.55. What is this Canada balsam? Canada balsam is a fine material through that the light can pass. It is a transparent medium. Now let us choose a unpolarized light. This is a unpolarized light. The unpolarized light, it has two vibrations. One is vertical vibrations. The vertical vibrations generally we are denoting with the double-ended arrows. And another one is horizontal vibrations. Horizontal vibrations we are denoting with dots. This polarization concept successfully explained that the nature of the light is transverse wave. Okay, ma. So now here it is one medium, it is another medium. We know that when the light rays are traveled from one medium to the other medium, refraction takes place. In this case, the refraction is taking place, but here the rays are divided into two rays. So one ray is called as extraordinary ray. That ray we are calling as E ray, extraordinary ray. So if you want, you can show like that. And another ray is called as ordinary ray. This ordinary ray is participating in the total internal reflection and comes in the another phase of the crystal. Okay, why it is participating in the total internal reflection? Okay, generally, ordinary ray and extraordinary ray, the speed of the ordinary ray is same in all directions. Same in all directions. That means if this ordinary ray is traveling along this direction, okay, that means along the optic axis direction or other than optic axis direction, the speed is same. Because of that one, the refractive index is also same. The refractive index corresponding to the ordinary ray we are denoting with mu suffix O, so which is equals to the 1.6584. Okay, but this extraordinary ray speed is not constant. Speed is not constant. So whenever it is traveling along the optic axis direction, okay, the speed is same as a ordinary ray. That means the time it will exhibit the refractive index is 1.6584. But other than the direction if it is traveling, this extraordinary ray, the refractive index is changes. Why? Because speed is changes. When both are perpendicular, the refractive index is, we can observe maximum change, that is 1.4864. Okay, so here this is a Canada balsam cement. Okay. This Canada balsam cement is acting like rarer medium for the ordinary ray and denser medium for the extraordinary ray. Okay. So this ordinary ray is here incident with greater than critical angle. Greater than critical angle. Okay, when the angle of incidence is greater than critical angle, what will happen is total internal reflection takes place. Okay, here the ordinary ray is incidenting with the greater than critical angle. So because of that one, it is participating in the total internal reflection. Because of that one, in one phase it is coming out. So that means one side only we will get only one type of vibrations. If the vibrations of the particles are confined to only one dimension, then we can call that is called as plane polarized light. That one we are calling as plane polarized light. That means by using this Nicols prism, we will produce the plane polarized light. These Nicols prisms we can be used as a analyzer and also the polarizer. Polarizer is a device to produce the polarized light, and analyzer is a device to which is analyzes whether the polarizer is producing the perfectly plane polarized light or not. Okay, that is the concept about the Nicols prism. Okay friends, thank you.